Okay, let's continue our discussion on production function. So we first defined what is a production function. So it basically tells you the relationship between input and output. So in this table, you can see that if you're given a number of workers and then you're given this output column, then these two columns will give you this production function. Obviously, if you draw these two columns on this picture, right, you could see that the production function looks like this. And then, very importantly, we mentioned the definition of marginal product, which is the increase in output divided by this increase in the input. That is, if you want a formula for marginal product, it is defined by delta Q divided by delta, let me think about a notation here. So let's use delta W, so number of workers, right? So let's say if number of workers increased from 2 to 5, and then output increased from 10 to 15. Right? In this case, you can see that marginal product is 5 divided by 3. And then a very important property of marginal product is as you increase the amount of input, marginal product will decrease. So this is called diminishing marginal product. And we talked about this explanation. So basically the reason is in our example, that is Helen's pizza kitchen. So in this Helen's pizza kitchen example, her kitchen size is fixed. This basically means as you increase the number of workers, in the end, the kitchen will become very, very crowded. So workers, they will actually start getting in each other's way. And this obviously will reduce their productivity. So this means that as you increase one additional worker, then this additional output from that additional worker will actually decrease. Now, so if you wanted to examine this diminishing marginal product on this picture, then you will observe that if marginal product is decreasing as you increase the input, then the picture, this curve, will have a shape like this. That is, first it will have a larger slope, then it will have a smaller slope. And as you increase the number of inputs, its slope becomes smaller and smaller. So let me explain this. So if you think about the definition of marginal product, so it's the change in output and the change in input, right? And now, what is the definition of a curve's slope, right? The definition of this slope is rise over run. Oh boy. So it's rise over run. In this production function curve, what is the rise here? Let's see how we could find out the rise. Let's say if we go from 1 worker to 4 workers. What is the rise? So this is the rise, right? What is the run? So the run is given by this. So this is the run. And what you can see here is the rise here is the same as the change in output, right? Because you can see that as you increase the number of workers from 1 to 4, the output increases from 50 to 140, right? So rise equals the change in output equals, I think it's 90. What is run? Here you can see that run equals the change in number of workers, right? Equals 3. So basically you can see that if rise equals the change in output and run equals the change in input, then obviously marginal product equals the curve's slope, right? So now we have got this result. Curve's slope is the same as the marginal product. Now, so we have learned this result of diminishing marginal product. So this basically says that as you increase your input, right, your marginal product becomes smaller. And because marginal product is the same as the curve's slope, so in this case, slope becomes smaller and smaller. And we know that for a curve, if its slope becomes smaller, then the curve will become flatter, right? So this means the production function curve, right, will become flatter. Okay, so you can see this result here. The production function curve gets flatter as the number of workers increases, which is the result of diminishing marginal product. Okay, now let's talk about the measurement of cost. This is somewhat complicated because we could have different kinds of costs. Remember that in the beginning of the chapter, we discussed implicit cost and explicit cost, right? And in that case, we know that depending on which cost you want to use, we will have accounting profit versus economic profit. To be more specific, if you're thinking about economic profit, then the cost has to include both implicit cost and explicit cost. And if you're just trying to calculate accounting profit, then you will only use explicit cost as the cost. So first, let me define these different kinds of costs. The first is the fixed cost. Well, this is easy to understand, right? So basically, fixed cost refers to the type of costs which are fixed during the production, right? And then we have variable costs, which means the type of costs which will change as you increase or decrease your output. Total cost, which is the combination of fixed cost and variable cost. So here we would use these short names, right? So FC refers to fixed costs, VC refers to variable costs, and TC refers to total costs. And then after define fixed cost, we can define average fixed cost. Well, this is easy, right? So basically, average fixed cost equals fixed cost divided by quantity. Right? So Q refers to the quantity of output. And then similarly, average variable cost refers to the cost, average variable cost refers to the variable cost which is divided by the quantity of output. Right? So AVC, average variable cost, equals variable cost divided by quantity. And then again, similarly, average total cost equals total cost divided by quantity. And because we know total cost equals fixed cost plus variable cost. So now we would see that average total cost equals total cost so average total cost equals total cost divided by quantity, which is fixed cost plus variable cost divided by quantity. And then this is just fixed cost divided by quantity plus variable cost divided by quantity. And then this gives you average fixed cost and average variable cost, right? So basically you can see that because total cost equals fixed cost plus variable cost, then we will have average total cost equals average fixed cost plus average variable cost. Then the last type of definition is marginal cost. We have learned about marginal product, right? So in the case of marginal product, it is defined by the additional output you can get divided by the additional input you have used. So in the case of marginal cost, whenever you're talking about marginal, it's always about changes or the ratio of changes, right? So in the case of marginal cost, it is defined by the increase in the total cost divided by the increase in the number of output. So basically from the formula, right, it basically says that this delta TC is the change in the total cost. And then this delta Q is the change of the output or the quantity of the output. Right? So this is the very original definition. Now, how do you understand this guy, right? Why do we get this second sort of definition here? Well, the reason is because the change in total cost equals the change in variable cost, right? So you can see that if you want to calculate marginal cost, you can use the change in the total cost divided by the change in quantity, or the change in the variable cost divided by the change in quantity. So let's first do some exercise, right? Let's calculate these different types of costs. So this is the example of Thirsty Thelma's lemonade stand. Right? Okay, so the first column, it's about the quantity of lemonade. In this case, you can see that the first column basically tells you the quantity of output, right? And then you can see that the fixed cost is given. It is $3. And you can see that no matter how many glasses of lemonade Thelma makes, the fixed cost is always $3. So it does not change with the number of output. And then we also have variable cost, which obviously will change if you change your output. So you can see that when the quantity is 0, then variable cost is also 0. And then when quantity increases to, let's say, 10, then the variable cost would become 12, right? And after getting a fixed cost and variable cost, we can basically find out what is the total cost. So by definition, total cost is the combination of fixed cost and the variable cost, right? So you can see here, if you add up these two numbers, you have total cost, right? Add up these two numbers, you have 5.4. And now let's find out average fixed cost. By definition, it is really the fixed cost divided by quantity, right? So you can see here, we can just pick any row, right? Let's pick this guy. It's 0.6, and you can see that if you use the fixed cost, which is 3 in this case. And what is the, oh, sorry. The fixed cost here is actually 0.75. So fixed cost here is 3, right? Average fixed cost here is 0.75. And then what is the quantity? It's 4, right? So you can see that, so, oh boy. What happened? Okay. That's pretty weird. Okay, so what is the quantity here? The quantity here is 4, right? So, because the quantity is 4 and the fixed cost is 3, so the average fixed cost would be 3 divided by 4, which gives you 0.75 here. And now let's try the average variable cost. So it's 0.6. And we can see that the variable cost here is 2.4. So 2.4 divided by 4 gives us 0.6. And now average total cost. Well, this is easy, right? So it's again just use the total cost divided by 4. So what you can see here is so the total cost is 0.4. So 0.4 divided by 4, this gives you 1.35. Now let's see how could we calculate the last column, marginal cost. So how do you find out this 0.5? Well, you can see that as you increase your output from 1 to 2, the total cost increases from 3.3 to 3.8. So it's 3.8 minus 3.3, which is 0.5. And you can see that we're using this definition here. That is, we're using the change in the total cost divided by the change in the quantity, right? And we also learned you can use the change in the variable cost divided by the change in the quantity. So let's see whether this can be used. So what is the change in the variable cost? Well, the change in the variable cost is 0.8 minus 0.3, right? So we're looking at these two numbers. And then the change in quantity is given by 2 minus 1. So now we have 0.5 here, right? So both methods give you the same result. Okay. Now let's talk about a very important property of marginal cost. It's called increasing marginal cost. It basically says that as you increase the output, the marginal cost will increase, right? So why do we get this result? Well, to put it simply, it's because of marginal product is decreasing. So if marginal product is decreasing, then marginal cost should increase. So why this is the case? Well, think about this, right? So let's say marginal product is decreasing. What does this mean here? It means that for additional worker, you get smaller output, right? So that's the definition of marginal product. So this basically means for the same, okay, let me change this. This basically means for additional output, you need more workers, right? Because we know that, well, these workers, they become less effective due to this diminishing marginal product. So if you want to get this additional 1 unit of output, if you want to make 1 additional product, you have to hire more workers. So in this case, it basically means for additional output, you have to pay a higher cost, right? Because you have to pay wages to these workers. If you have to hire more workers, then you have to pay higher wages. So in this case, it means marginal cost is increasing, right? So essentially, increasing marginal cost is implied by decreasing marginal product. Okay, now let's talk about this from the perspective of using this picture, right? Okay. Oh, what happened? This app does not work again. Okay, that's weird. Sorry for that. I have to reopen this PDF. So this app is basically no good. Okay, good. So if we draw out these two columns, we can find out, or we can draw our total cost curve, right? So how do you draw this total cost curve? Well, you can see that, okay, let me draw it here. So this is quantity, and this is total cost. From this table, we know that if quantity is 0, right, then the total cost is 3. And if quantity is 1, then we get 3.3. And if quantity is 2, we get 3.8. And obviously you can do this for each quantity until you get to this 10th quantity, right? And then you will get all these points. And obviously if you connect these points, you will get a total cost curve, right? So basically it's very easy to convert this table, right, to this total cost curve. Now if we look at this total cost curve, what we can see here is, first, obviously, as you increase the quantity, then total cost should increase. So this total cost curve should upward sloping, right? And then we also observe that it's we could also see that the slope of this total cost curve gets larger and larger as you increase the quantity of output, right? You can see that here we have smaller slope here. Why do you know you have smaller slope? Well, because it is flatter, right? And here we have larger slope. Why do you know this? Well, because it is steeper, right? Now, why do we get this result? Well, it's really because of the increasing marginal cost, right? Because marginal cost equals the slope of this total cost curve, right? And if marginal cost increases as we increase the quantity of output, then we would know that slope should also increase as we increase the quantity of output. So this implies that slope will be larger as we increase the quantity of output. So the curve, the total cost curve, will become steeper and steeper as we increase the quantity, right? Oh, by the way, how do you know marginal cost equals the slope of the total cost curve? Well, it's a similar argument, right? We talk about this y marginal product equals the slope of the production curve, and we used the definition of rise over run. Well, in this case, it's the same. Again, you can see here, right? So this is the rise, and this is the run. And rise obviously equals the change in the total cost. And run obviously equals the change in the quantity. So the definition is rise divided by run, which gives you the curve's slope, and this should be the same as the change in the total cost divided by the change in the quantity, which gives you the marginal cost. So marginal cost equals the slope of the curve. Okay. Now let's summarize what kind of costs we have learned. The first two are from the first part of this chapter, right? Explicit cost and implicit cost. Remember that if you can see a outlay of money from the firm, then it is an implicit cost. And if you cannot see this outlay of the money, then it is an implicit cost. And next we have fixed cost, variable cost, and total cost, right? Fixed costs refers to costs which are fixed during the production, right? And variable costs refers to costs which does not change if you increase or decrease your output. And total cost, by definition, is the sum of fixed cost and variable cost. And then based on the definition of fixed cost, variable cost, and total cost, we can define average fixed cost, average variable cost, average total cost. And all these three kinds of costs are defined by their respective costs divided by quantity, right? For example, average fixed cost is just fixed cost divided by quantity. And then at last you have marginal cost, which is the change in the total cost divided by the change in quantity. Okay, now let's finish this quiz here. So if Farmer Jones plants no seeds on his farm, he gets no harvest. If he plants 1 bag, then he gets 3 bushels of wheat. 2 bags, 5 bushels. 3 bags, 6 bushels. And a bag of seeds costs 100, and seeds are his only cost. So use this data to draw out the farmer's production function and total cost curve and explain their shapes. Okay, you can see that this is a pretty easy exercise. So let's start with production function. Right? Okay. So let me use this little space here. So production function, you remember that it's about output Q and input. So what's our input here? So here input are bags of seeds, right? So let me call this as S, which means seeds. So the farmer can have 0 bag, 1 bag, 2 bag, and 3 bag, right? And then let's mark some numbers down. 1, 2, 3, 4, 5, 6. So if there's no seeds, he gets no harvests, right? So the point is here. And if he plants 1 bag of seeds, he gets 3. So it's here. 2 bags, he gets 5. It should be here. 3 bags, he gets 6, which should be here. Right? And now let's connect these dots. So this will give us the production function curve, right? What you can see here is the curve becomes flatter and flatter, right? That is, the slope of the curve decreases as you increases the bags of seeds. So this is exactly the result of diminishing marginal product, right? Okay, now let's draw out the total cost curve. So if it's about total cost curve, then the vertical axis is about the total cost. Horizontal axis is about quantity, right? So we could have 0, 1, 2, 3, 4, 5, and 6. Now let's see what kind of costs do we have here. So if he plants 0 bag of seeds, right, there's no cost. Okay, maybe first let me write some number here, right? 100, 200, 300. Okay, so the first dot is given by this, and then the second case is he would get 3 bushels of wheat. In this case, he needs to plant 1 bag of seeds, and per bag of seeds costs $100. So we get a dot here. And next, he could get 5 bushels, and in this case, he needs to plant 2 bags. So we get this point. And next, 6 bushels, he plants 3. And then if you connect this total cost curve, then you can see that it gets steeper as you increase the output level, right? So this is basically the result of increasing marginal cost. Okay, we have another exercise. So this exercise asks you to fill in numbers, right? So what kind of numbers do you want to use here? And then you can see that for this column header, you have quantity, variable cost, total cost, average fixed cost, average variable cost, average total cost, and marginal cost. Right? So what is this? So what is this? Well, I can see that here quantity is 0. So fixed cost has to be 0. Right? So we could put 0 here. Now what about this guy? You have to find out total cost. And by definition, total cost equals variable cost and fixed cost. Here we have variable cost, which is 10 here. But how do you find out the fixed cost? Well, one way to find out this is this is your fixed cost. The reason is because if the quantity is 0, then it means variable cost is 0. So in this case, total cost equals fixed cost plus variable cost, and fixed cost plus 0, right? So in this case, you can see that if total cost is 50, then fixed cost is 50. Right? So this is one way to find out the fixed cost. Then this will tell us total cost should be 10 plus 50, which is 60, right? And then you could use a different way. That is, you can see that average cost here is 60, and you have only one quantity. And by definition, total cost should be equal to average total cost times quantity. So now you will directly find out the correct number, 60. Now, average fixed cost. Well, you can see that average fixed cost equals average total cost minus average, so average fixed cost equals average total cost minus average variable cost. So this gives you 50, right? And now let's continue to do another row. Now for the quantity at 2, we can see that average fixed cost. Well, we know that the fixed cost is 50, right? So here we should put down 25 here. Average variable cost, right? It's variable cost divided by 2, which is 15. What is ATC here? So average total cost. And we see that total cost is 80. So average total cost is just 80 divided by 2, which is 40. Now what about marginal cost? Well, marginal cost, you can see that as you increase from 1 to 2, total cost increases from 60 to 80. So in this case, you can see that marginal cost is 80 divided by 60. Sorry, 80 minus 60 divided by 2 minus 1. So this gives you 20. Okay, you can see that, for exercise, when you're watching this video, or sorry, when you have finished this video, you should really try to solve these, right? Find out these numbers. And you can see that you have answers here. So you can compare your answer with this, with the answer given in this lecture note. Okay, next let's talk about another topic, which is the relationships between these different cost curves and their shapes. So, so this picture gives you the marginal cost curve, average total cost curve, and average variable cost curve, and average fixed cost curve from this Thirsty-Thelma's example. How do you get this curve? Well, it's very easy because you have this table here, right? Because you have this table here. What you need to do is you would just draw this quantity on this horizontal axis. And if you want to find out this average fixed cost curve, then you will just draw these numbers on the horizontal axis. Sorry, on the vertical axis. The same, the same approach, right? For this average variable cost, if you want to find out the average variable cost curve, then you will just draw this curve with quantities on the horizontal axis and average variable cost curve with average variable cost on the vertical axis. Then you will get your average variable cost curve. So what's our observation here? The first, you can see that marginal cost rises with output, right? So this is the marginal cost. This is very understandable because we know that marginal cost increases as you increase output, right? So obviously, marginal cost curve would look like this. And then average fixed cost decreases with output. Well, this is pretty easy to understand because by definition, right? AFC equals FC divided by Q, right? And fixed cost is a number. It's fixed. So it means as you increase quantity, right? So as you increase quantity, then the average cost should decrease. So that's why you could observe that average fixed cost curve decreases with the output. Then ATC is U-shaped, right? This is a important result. So let's see which one is the ATC curve. So this guy is the ATC curve, and you can see that it's U-shaped, right? And we could also see that the marginal cost curve crosses the ATC curve at its minimum point. That is, this point is the minimum point of the ATC curve. Or you could say this point is the lowest point of the ATC curve. And the marginal cost curve will exactly cross this lowest point on this ATC curve. Right? So let me explain why do we get these results. First, why do we get this U-shaped average total cost, right? Well, if you recall what we have learned about the definition of average total cost, it's the combination of average fixed cost and average variable cost, right? And you can see that in terms of pictures, it means that if AFC curve looks like this, right? Because we know that AFC curve will decrease as we increase quantity. And then generally AVC curve will decrease because marginal cost increases. Generally average fixed cost will increase because marginal cost increases. So this is the AVC curve. And we know that AFC is the combination of these two curves. Now think about this. How this ATC curve will look like if we combine the AVC curve and the AFC curve. Well, you can imagine that it has to look like this, right? So this is the ATC curve, right? So you can see that the U-shaped ATC curve is very easy to understand once you decompose this ATC curve into AFC curve and AVC curve, right? Okay, so on this ATC curve, we can define efficient scale. What is the efficient scale? Well, it's the quantity of output which minimizes average total cost, right? So it basically means that if you have a average total cost curve look like this, and you can see that this quantity would be your efficient scale, right? Because at this quantity you get the smallest average total cost. And we have a small question here. What is Thirsty Thelma's efficient scale? So let's see what is her efficient. So judging from this picture, right? Let's see what is the lowest point of this ATC curve. Right, so you can see that it's this quantity. I guess this is a quantity of 5, right? So I guess this picture is not the best picture. Now let's look at the table here. So let's see at what quantity the average total cost is the lowest, right? I see. Now we have two numbers, right? So you can see that the average total cost is around 1.3 when the quantity is 5 and 6. So possibly I would guess at the quantity of 5.5, then the average total cost is about, I guess, 2.5, right? So the efficient scale is about the efficient scale is about 5.5. So if we look at this picture here, you can see that, yeah, you can see that at 5, we get 1.3 ATC, and it's at the quantity of 6, we get 1.3 of the ATC. So you can see that the middle point is given by 5.5. So 5.5 would be the efficient scale here. Okay. Okay. Now, let's talk about the relationship between marginal cost and average total cost. Well, we have mentioned this, right? We know that marginal cost crosses the ATC at its lowest point, right? So you can see that in this thirsty Thelma's case, we exactly get this result, right? Because this is the lowest point, right? Now, why do you get this result? So we could get a very nice analogy from the textbook. It's about your next semester course at your GPA. So let's say your current GPA is 3.8, right? Now, let's think about your next semester course or your next course. Your next course. Okay, let me write it maybe here. Okay, so let's say your current GPA is 3.8, and then now let's think about your next course grade, right? So let's say the grade in your next course is 3.9. Now you can see that your GPA will increase, right? Let's say if your next course grade is 3.5, then your GPA should decrease, right? So this result is pretty easy to understand. And if you can understand this result, then you will be able to understand how marginal cost curve and the ATC curve are related. The reason is because the marginal cost curve is just like your next course, right? So these are the analogy to this marginal cost. And then your current GPA is an analogy to the ATC curve, right? So basically you can see that if your next course mark is higher than the current GPA, then your GPA will increase. So if you accept the analogy here, then you could see that if marginal cost is larger than the average total cost, then average total cost will increase, right? What does this mean here? So it means that if marginal cost curve is larger than the average total cost curve, then average total cost curve should increase, right? And then if marginal cost curve is lower than this average total cost curve, then average total cost curve should decrease, right? So you will get this exact same result. That is, marginal cost curve crosses the ATC curve at its lowest point, right? You can see that this curve exactly fits into our result, right? Because again, you can see that for this section, right? You can see that marginal cost is smaller than average total cost, and average total cost curve decreases. And in this section, marginal cost is larger than the average total cost. So in this case, average total cost increases. Right? Okay. So these curves we just mentioned. Okay, yeah. These curves we just mentioned, they're based on this Thirsty Thelma's example, right? So there could be some differences between this example and a typical firm's cost curves. So for a typical firm, their cost curves would be like this. What you can see here is for a typical firm, it's possible that the marginal cost will actually decrease in the beginning. Right? If you look at this section here, you can see that marginal cost decreases if you increase quantity, right? Why do we get this result? Well, because in the beginning, if we have more workers, then we could actually benefit. Basically, if we increase the number of workers, then there could be better division of jobs, and then there could be better exchange of experiences, and then there could be some synergies between different workers. So this will increase productivity of these workers. So that's why you could see a decrease in marginal cost when you increase the quantity in the beginning. However, you can see that ultimately, or in the end, right, marginal cost will increase as you increase the quantity. Right? So you can see that this decreasing marginal cost curve case will only happen in the beginning, or when your quantity was relatively very small. Okay, now let's summarize what we have learned about these different types of curves. So first, marginal cost will eventually increase as you increase the quantity of output. And second, the ATC curve and AVC curves are U-shaped. Right? So if you look at this typical firm's cost curves, you can see that both ATC curve and the AVC curve, these two curves, they're U-shaped. And third, the marginal cost curve will cross the ATC and AVC curves at the minimum point of ATC and AVC. Right? So what you see here is these are the low. So this one is the lowest point of the ATC curve, and this one is the lowest point of the AVC curve. And marginal cost curve will exactly cut through these 2 points. Okay, now let's finish this very simple example. So suppose Honda's total cost of producing 4 cars is $225,000, and its total cost of producing 5 cars is $250,000. So what is the average total cost of producing 5 cars? What is the marginal cost of the 5th car? Well, this is easy. You just need to use the basic definition. So average total cost is given by the total cost of 5 cars, that is 250,000, divided by the number of cars. So this gives you $50,000, right? Now the marginal cost. So according to the definition of the marginal cost, we have the change in the total cost divided by the change in the quantity. So this gives us $25,000. Right? Okay. Now let's talk about the last topic in this chapter. That is the costs in the short run and in the long run. So through this chapter until now, right, we always maintain a important assumption. That is, we assume that the firm can only change the number of workers, but the firm cannot change the size of the factory. Right? To be more specific, in the Hungry Helen's cookie factory example, we assumed that the size of the kitchen is fixed. And you can see that this kind of assumption is only correct when you're just thinking about short term, right? Because in the long run, you can definitely change the size of the kitchen, right? So based on this, you can guess that the cost curves in the short run and in the long run should be different, right? Because in the long run, the firm has more or higher flexibility, right? It can change anything. It can change any inputs, including factory size. Okay, so this picture basically gives you the relationship between short-term ATC curves and long-term ATC curves. Okay, so let's see what's this picture can tell us. First, horizontal. Well, horizontal axis gives us the quantity of cars. So obviously this is a car factory example. And then the vertical axis, right, talks about money. That is the average total cost. And these three blue curves gives us the average total cost in short run with different sizes of factories. And then this red curve gives us the ATC curve in the long run. Obviously, you can see that we have much more information from this picture, right? Compared with previous pictures. So it's a complicated picture. Okay, now let's see what kind of result we can get here. The first obvious result is you can see that this red curve is always under these blue curves, right? What does this tell you? Well, this basically says that average total cost curve. This basically says that average total cost in the long run is smaller compared with average total cost in the short run, right? So why do we get this result? Well, the reason is because in the long run, firms, they have more time to make adjustments. So this basically means that firms have larger flexibility in the long run. So this basically tells you that in the long run, these firms can make better choices in organizing their productions. So the ATC curve will be lower, right? So you can see this simple example here. You can see that, let's say, initially, the firm was producing 1,000 cars. And then one day, the firm decides to increase to 1,200. But you can see that, let's say the firm has a medium-sized factory. You can see that if the firm wants to jump from 1,000 cars to 1,200 cars, then there's no way this firm can immediately increase the size of the factory, right? So you can see that it will have to stick to this short run ATC curve, right? So if the firm has if the firm has to be on this short run ATC curve, then you can see that as the firm increases from 1,000 to 1,200, then the firm will have to pay this cost. That is $12,000, right? Now, think about what would happen in the long run. Well, in the long run, obviously, the firm can actually expand its factory. So the firm will be able to do better in the long run. What does the word do better mean here? It basically means that in the long run, the firm will be able to reduce the cost from $12,000, right? So the cost will be lower in the long run. That is, right? You will see that there would be this lower cost in the long run. So in this case, you can see that we assume in the long run, the firm will actually be able to pull back from $12,000 to $10,000. Right? Okay. The second observation is this long run ATC curve is a U-shaped ATC curve, right? So it's still U-shaped. And more than that, you can see that we have three different cases. The first case is given by this section, right? Interestingly, this section basically says if you increase the quantity of cars, then the average total cost will be smaller. And then we have this section, right, marked in this different color. You can see that here, as you increase the number of cars, then the average total cost is fixed. It is $10,000, right? And then we have this third section. Right? Marked in yellow color. In this case, you can see that as you increase the number of cars, then ATC will be larger, right? So, according to how ATC will change with respect to the quantity of cars, we would define different kinds of economies of scale. So we will have three different definitions, right? Economy of scale refers to the case that the long run average total cost will decrease if you increase the output. That is, we're talking about this section here. And then constant returns to scale means the average total cost will stay the same even if you increase or decrease the output. That's why you get the word constant. Right? So you can see that. And here we have the constant returns to scale. And then we have the third definition, which is the diseconomy of scale. And what you can see here is basically as you increase the quantity of cars, then the long run average total cost is increasing, right? So you can see that we're talking about this section here. So we're having the diseconomies of scale in this case. Okay. Now, why do we have economies of scale here? Well, it's because in the beginning, right, the firm can actually get some benefit as the firm increases its output. The reason is because when the firm has more outputs, then fixed cost can be divided into different quantities. That is, by the definition of average fixed cost, right? Basically, if quantity increases, then average fixed cost decreases. So you can see that the decrease in average fixed cost will benefit this firm. So this firm can have a lower average total cost in the beginning due to the decrease in the average fixed cost. And then there is this other economic reason. It's because as the firm increases its output level, then there will be more specializations among its workers. And then you can see that workers will be better at their own specific task. This will increase productivity, which will reduce the average total cost. Clearly, you can see that this will only happen, right, in the beginning, right? It will only happen here. That is, when the quantity wasn't too large. Now, why do you get these economies here? Well, this will happen because the coordination problem. That is, if your firm becomes larger and larger, then it becomes harder and harder to coordinate between different workers, between different divisions in your firm, right? So this will reduce the efficiency of your firm, which will increase your average total cost. So now you will get these economies of scale. Now let's look at this quick quiz here. So if Bombardier produces 9 jets per month, its long-run total cost is $9 million per month. And if it produces 10 jets per month, its long-run total cost would be $9.5 million per month. Does Bombardier exhibit economies or diseconomies of scale? Well, we will just do this according to definition, right? So if there are 9 jets, average total cost would be 9 divided by 9, which is 1. If there are 10 jets, average total cost would be given by 9.5 divided by 10, which is 0.95. So you can see that here we basically have the result. That is, if quantity increases, and then average total cost would actually decrease, right? So this implies that this firm has economies of scale, right? Okay, great. Now let's look at true false questions. Okay. So the first one says the average total cost curve reflects the shape of both the average fixed cost and average variable cost curves. We actually talked about this, right? Because you can see this by definition. ATC equals AFC plus AVC, right? And we also discussed that the ATC curve is just a combination of the AVC curve and AFC curve. So basically you can see that the first true-false question is actually correct. Second, if the marginal cost curve is rising, so is the average total cost curve. Well, remember we learned ATC curve and marginal cost curve will look like this, right? So you can see that this second statement is false. The reason is you can see this section. Okay, let me draw a better picture here. Oh boy. So let's see these two sections of the ATC curve and the marginal cost curve. What you can see here is marginal cost is always increasing. However, here on this left-hand side of this curve, this ATC curve is actually decreasing, right? So this is false. Now, what about the third one? The cost of producing a additional unit of a good is not the same as the average cost of the good. Well, obviously this is right, because the cost of producing a additional unit of good is the definition of marginal cost. Obviously, marginal cost is not equal to average cost. So this is true. Because of the larger flexibility that firms have in the long run, all short-run cost curves lie on or above the long-run curve. Well, this is true, right? Because we learned this is the long-run ATC curve, and then the short-run curve would look like this, right? It will always lie on this ATC curve. Okay, fifth, the marginal cost curve intersects the average total cost curve at the minimum point of the average total cost curve. Well, this is exactly what we have learned in the lecture note, right? So you have ATC and MC and the marginal and the marginal cost curve will cross this ATC curve at its lowest point. So this is correct. 6. Economists normally assume that people start their own businesses to help society maximize its income. Well, this is false. Let me explain why. So this question actually tries to test your understanding of a firm's purpose. So in economics, we generally assume a firm's purpose is to maximize its own profit. So you can see that the correct statement here is economists normally assume that people start their own businesses to help maximize their own income or their own firm's profit. So it's not about benefiting society. It's not about help society maximize its income. So this is false. 7th, implicit costs are costs that do not require an outlay of money by the firm. Well, this is the exact definition of implicit cost, right? So implicit cost does not require the outlay of money, and explicit cost requires the outlay of money. So this is correct. Okay, 8. Average total cost and marginal cost are merely ways of expressing information that is already contained in a firm's total cost. Well, this is actually right. The reason is because if you give me total cost, I can tell you marginal cost, right? And I can tell you the average total cost. So this basically implies that average total cost and marginal cost, they're just this different way to talk about or to express information contained in a firm's total cost. So this is correct. Okay, 9th. These economies of scale often arise because higher production levels allow specialization among workers. Well, this is not correct because specialization among workers should benefit the firm. So this should generate economies of scale. It's not these economies, right? So this is false. 10th, economists and accountants both include foregone income as a cost to a small business owner. This is actually false. What is foregone income? So it basically says if you want to start your business, you cannot work as a software engineer, so you have to forego the wage you could earn from being a software engineer. So in this case, you can see that the foregone income is an implicit cost, right? So that's the key here. So it's the implicit cost, which means economists will include foregone income as a cost, but accountant will not include this as a cost. Or you could say that for this foregone income, you will not actually see this cash outlay. So the accountant will not record this. Now, okay, the last one. The average total cost curve is unaffected by diminishing marginal product. So you can see that we're talking about the average total cost curve. This is actually somewhat confusing. So we know that diminishing marginal product, right? It will generate increase in marginal cost, right? And we know that marginal cost will affect total cost. And total cost will definitely affect average total cost curve. Right? So this is false. Okay, that's for today's lecture.